Hello and welcome to another exciting video here in Mathland. Today we're going to talk about the domain of a function, non-graphing. So just looking at the functions as they are, we're going to determine the domain of the function. Okay, so let's see what we've got here. We've got h of x equals 10 over x squared minus 2, and we have f of x equals square root of 4 minus x squared. Okay, so let's go ahead and work these out. What I'm looking for when I have a fraction or a rational expression here as a function, I'm just going to look at the domain, and what can we never have in the denominator. What can we never have in the denominator? We can't ever have 0, so I'm going to look at the denominator and set that so it can't ever equal 0. It can't equal 0. So I'm going to factor as best I can the denominator. If you can, go ahead and factor it. If you can't, that's okay. Just solve it the way it is. So I'm going to bring out an x and then an x minus 2, and it can't equal 0. So I'm going to separate these as if I was solving for x, only I'm going to set it to not equal 0 here. So I've got x cannot equal 0, and x minus 2 cannot equal 0. So just treat it as an equal sign, and then x cannot equal positive 2 if we move the 2 over there. Okay, so these guys are part of our domain. They're actually going to be vertical asymptotes, so your answer for the domain would be all real numbers except x cannot equal 0 and x cannot equal 2. Okay, so that is your answer for that. That's the domain of this function here. Let's move on to this one. I've got f of x equals the square root of 4 minus x squared. Now, similarly, we have restrictions on radicals, just like we had a restriction on a denominator, if that was involved in a function here. But since we have this restriction here on the radical, we can't have negatives inside the radical, remember? So we're just looking at what's inside the radical. Nothing else matters in finding the domain of this function. We're going to set this to be greater than or equal to 0. So everything in here has to be greater than or equal to 0. It can equal 0, that's fine, but it can't be negative. So any positive number, including 0, has to be our domain. So I'm just going to solve as an inequality here. It has to be greater than or equal to 0. So let's go ahead and factor this. We can factor. So we have 4 minus x and, 4. Not 4, let's try it again. 2 minus x and 2 plus x is greater than or equal to 0. Okay, now let's solve for each one, just like we broke it apart here when we have two separate we have a product of two terms. So we have two binomials here. So we have 2 minus x is greater than or equal to 0. And over here, I'm going to separate this one. 2 plus x is greater than or equal to 0. Okay, so solve for x here. I'm going to move my 2 to the other side. So I'm going to subtract 2. And we have a negative x is greater than or equal to negative 2. Now here, remember, when we're dealing with inequalities, we're going to divide by a negative 1, and that's going to cancel out here, but it's also going to flip our sign, so x is going to be less than or equal to 2, okay? And then over here, let's go ahead and solve over here for x. So I'm going to subtract 2, so x is greater than or equal to negative 2. Okay, so if we join these together, it says that x is less than or equal to 2, and x is greater than or equal to negative 2. So we're going to put that together as 1. So negative 2 is going to be greater than or equal to that. X is in the middle, and it's also less than or equal to 2. That's our domain restriction on this one, meaning it won't go farther than negative 2 when we graph it, and it won't go farther than positive 2 when we graph it. So it's just a restricted area, whereas this was an asymptote. So things could go on to the left or right of this, and it couldn't cross the asymptote. But this is a restriction of the graph, that it can't go beyond those points. And that's it. That's finding the domain of a function in a non-graphing way.